Hello and welcome to this session titled Coding Landing Zone for Infrastructure as Code Development. As part of Azure Back to School 2025, a technical community event with a long tradition, you're about to discover best practices for setting up a robust coding landing zone using infrastructure as code, namely Bicep on Azure, and why this approach is vital for modern cloud solutions. A big shout out to Dwayne, Derek and the rest of the organizing team for hosting this event and providing us the opportunity to contribute. I've participating for a couple of years now, and it's always a pleasure to share my experience and learn from others. A few words about me. I work as a principal solution architect at Segal, a company that is mainly focusing on power and utility industry. I'm a public speaker, attending various conferences, and a member of several communities like Azure Landing Zone, the Bicep community, Azure Verified Modules, and Terraform on Azure. I'm a co-organizer of two user groups here in Norway, Azure User Group Norway and Infrastructure as Code User Group Oslo. You can find us on meetup.com. If you want to get in touch, I have a universal handle on GitHub, LinkedIn, Sessionize, SpeakerDeck and X. Or you can check my blog at azurescholar.cloud. So, what are we going to talk about today? First, I will give you an overview of the coding landing zone concept and what it includes. Then I will give you a walkthrough of the code base that shows you those capabilities in practice. It's a public repository in GitHub, so you can use it today. After the walkthrough, I will talk about another community project called AZ Bootstrap and how you can combine my template repository with this great tool to accelerate your development of IAC code, focusing on Azure Bicep, but it can be extended for other IAC languages like Terraform. In the end, I will do a demo that shows it all. So let's get started. The idea of a coding landing zone is quite simple. It is a repository template that you can instantiate for every IAC project that would contain everything you need without you thinking too much or creating it from scratch. And we are talking about several components available in this repo. A standard repo structure with recommended files for the given IAC tool, in this case Bicep. Then it's a set of CI/CD workflows that are designed to give you all the important validations and testing for security, best practices and so on. Those workflows should ideally come from a reusable workflows, which is a very common scenario for GitHub Enterprise Cloud organizations. You have a central repo where you publish and version those workflows and you create caller workflows in the repository template. For teams using VS Code, the repo contains JSON files with recommended extensions, with tasks you can run locally to support your development, and with some settings that will make the IAC configuration easier. Then you have some configuration files themselves, specifically bicep config.json and PS rules YAML, which is, by the way, a very important tool in our workflow. And since everything is about AI these days, then obviously we can't forget about embedding support for GitHub Copilot that is tailored specifically to IAC projects using Bicep. Lastly, I'm a big fan of dev containers and GitHub code spaces. So this repository template also contains their support, so you can easily get started without installing many tools and modules on your dev machine. If you are a part of an organization that hosts their own Bicep private registry, as opposed to only consuming modules from the MCR registry, then you could also add aliases pointing to that registry yourself. Let's switch to VS Code for the code walkthrough now. And we'll begin from the top. Dev container support. It is a JSON configuration file where you specify the source image. Then you can leverage features for adding tools like Azure CLI, PowerShell. You can even include specific modules you would like to have, GitHub CLI, and others. Then it's a customization. In this part, I'm focusing on settings for Visual Studio Code, adding different profiles for Linux, Windows, and Mac OS for the integrated terminal. Then some configuration for GitHub Copilot support and the editor. In the end, I'm specifying what useful extensions I want to have added. So things like the most important Bicep extension, PowerShell, GitHub Copilot, of course, and a few more are automatically added. The second directory, the GitHub directory, is the biggest one, as it contains a lot of configuration and logic. Let's start with Copilot instructions. This is the main file for GitHub Copilot, where you can describe the project. Of course, since this is a template, it contains a very generic description of an infrastructure as code project. What are the key components, how the repo is structured. You can modify these things for your purpose. How the developer flow look like, what patterns and conventions you want to include. But this is quite generic, and as you will see in a second, I also added specific instructions for Bicep, because you can now separate those. So this is the main Copilot instructions file, and when I go on the instructions subdirectory, you see Bicep instructions. And the most important part is that it's applying only to files with Bicep extension. And here you can add your coding standard, your preferences, how you want to structure and declare various things. If you want or don't want to use decorators, and if you want to add support for Azure verified modules. I've tested this configuration, and it so far has been very, very helpful. Optionally, you can also add some pull request instructions if you like to get help from Copilot to shape your pull requests in a specific way. The second directory, prompts, this is where I just started with some experimenting. The idea is that you can create those prompt files, again in Markdown, where you specify the instructions with the given prompt for a specific mode like edit, etc. The workflows, as you can see, I'm using 3 workflows. The first one is test Azure Access. So how many times have you tried to set up your CI/CD workflows in GitHub only to learn that there are a lot of things missing? So this is a very simple workflow that only tests whether you have the right access, or more specifically the workload identity that you used to configure the workflows have the right access. And as you can see, I'm leveraging those reusable workflows. So it's not you don't see a lot of code directly here. We will switch to that repository that I placed under my sort of GitHub alias. This is a special repo that contains your public profile, but you can store a lot of other things there, like those reusable workflows. The CI look very similar, but I'm specifying only certain triggers, like push to the feature branch, and there is also a path filter, or pull requests. Eventually you can run it manually through workflow dispatch. Some needed permissions, and then again for the jobs, I'm using that reusable workflow, or calling it, and I'm injecting certain parameters. All these things you can modify yourself, and the same goes for CD, where it's only responding to the push to the main branch trigger, again using that same path. It's just a different YAML file in that shared repository. But they are leveraging the same secrets. I really like using Dependabot. So this is a configuration for both GitHub Actions and dev containers. Whenever there is a new package or new component that I'm using, or the actions themselves that I'm using, that the new version gets published, I get notifications from Dependabot, or it even creates a pull request asking me if I want to bump the version of those components, which is very, very useful. Optionally, you can also add a pull request template. So if you have certain standard for definition of done, for instance, you can add these things here, so it acts as a checklist for everybody who creates a new pull request, and you can make sure that you have consistency and the right level of quality for your work. The tours directory actually contains a code tour. If you know that extension for Visual Studio Code, it gives you an ability to codify a walkthrough of the code base like this. All you need is that code tour extension, and then you will run the tour that someone created for you. So you can highlight specific sections in your code base, add useful instructions, diagrams, and it will give a nice walkthrough for anybody who wants to get onboarded to that code base. The VS Code itself, the extensions you can see as recommendations. These are the same that I used in the dev container. So depending if you're using synchronized configuration in Visual Studio Code, if you don't have these extensions installed, there will be a pop-up giving you an option to install those on top. In the settings files, I'm only adding support for specific Copilot configuration. And in tasks, this is just the first attempt to add some tests that I would like to run locally. I can think of additional tasks like running Pester. But here I'm launching PS rule. It will use that PS rule YAML file you see in the root of the repo, and it will run the PS rule tests against the infrastructure configuration that I will show you right now. So the actual Bicep configuration is stored in the infrastructure directory, and this is just like a scaffold of something, like creating a resource group, setting target scope, and there is obviously a respective Bicep configuration, Bicep parameter, file. Those are just placeholders, and you can change them before you use this template repo and promote it internally in your team. In the end, the Bicep config.json, which is of course very well known to anybody who is using Bicep. You can specify certain rules for Bicep linter, and at the bottom you see that there is also an option to add aliases for either template specs or Bicep registry. The last one is psrule.yaml, which specify how you can use psrule and psrule for Azure, what rules you want to include, what you want to exclude, these kind of things. When I was talking about the reusable workflows, I probably should now show you that central repo where I store them. So let's quickly go into this one. So we have the platform template Bicep CI. So in this CI workflow, it has the workflow call workflow call trigger, and you can recognize those inputs that are declared in this place, and as long as they are not as they are required, I need to specify them also in the caller workflow in that template repo. But the main logic is I'm using some environment variables because I'm supporting deployment to different scopes, not just subscriptions, but also resource groups and the management group. I'm doing linting, no surprise here. Validation, I'm using those secrets to authenticate to Azure. Those secrets will come in form of OIDC federated credentials, so no real secret value or some shared passkey or anything like that. Then for security scanning, I'm using PS rule with configured security pillar, so it only does that. I experimented with several other security scanners. Most of them don't support Bicep directly. You need to first transpile it to ARM.json. But I found PS rule with this baseline as sufficient without using those third-party scanners. And then there is a PS rule job that focuses on best practices validation, so it can run against a baseline that is focusing on well-architected framework and all the rules and recommendations that come with it. And then of course you have a what if job that needs all these previous 3 jobs to complete, and it will only run under certain conditions. Mainly it needs to be a pull request, so it won't run this job will not run only based on commits to a feature branch. And this ends the what if part. As you can see, in all those steps, I'm using the new Bicep deploy GitHub action, now already in version 2.2.0. The CD workflow has a very similar structure, some inputs that I just pass on, so you can override like the paths to your main.bicep or some other things. And then it runs what if validate, so it's a different configuration of that Bicep deploy action. As you can see, there are different values injected. And lastly, there is deployed Bicep job, which only runs when the previous what if validate succeeded, in case it is actually pushed to the main branch, or the head points to the main branch. So only after you successfully approve the pull requests and it gets merged, your feature branch that is. And it's using, or there is an added support for GitHub environments. So if you know how they work, you can add manual approval for that environment. So since this runs on an environment, you can configure your repo to have that approval step. So someone who is doing the final check will also validate the previous step, which is the what if, to see what it will actually change. And after that, it will do the actual deployment. Now let's talk about AZ Bootstrap. This is a community project led by Stu Mace, an MVP from New Zealand. And in its essence, It's a PowerShell module acting as a wrapper for AZD, or Azure Developer CLI. As you can see in the diagram on the right, it does a lot of useful things that you would otherwise have to do manually or write your own automation. It creates a new repository from a GitHub template you provide. It clones the repository locally. It creates a resource group on Azure with managed identities that will be used in your workflows. It assigns the RBAC roles to those identities, so your workflow has a permission to perform those actions. Optionally, it could also create a storage for Terraform state in Azure. Then it creates GitHub environments, sets necessary secrets for OpenID federated credentials, and in the end, it adds reviewers for the environments and branch protection policy, or rule sets. This tool has a lot of configuration options exposed as parameters for that PowerShell module. You can either provide your values interactively or use a configuration file. I stumbled on this project when I was exploring options of expanding my repository template with the ability to add all that necessary configuration on both GitHub and Azure side. I tested it with my template repo and it works great. Now it's time for the demo. I switched to my terminal and I'm in the PowerShell session, as you can see. And I should first check a couple of things. Namely, do I have AZ Bootstrap PowerShell module installed? I can use get module, name AZ Bootstrap list available, and it is indeed available. If you don't have it available, you would obviously use install module name AZ Bootstrap commandlet. Then I want to check, since the tool requires AZ CLI and GitHub CLI, I need to check if I'm logged on to those tools. So AZ account show. Yes, that's the correct test tenant, the subscription that I want to use. Get AZ context, just to make sure that I'm logged on to the same environment. And GitHub auth status. Yes, I'm logged into github.com using my account. So now all you need to do is to use invoke AZ Bootstrap. And like I said, you can do it either interactively or you can provide all the values right in the command line. So what I'm using is the second option, where I'm injecting values for template repo URL, target repo name, location for my Azure resources, target directory where I want this repo to be cloned, GitHub repo visibility for that project, and then some custom naming convention if you use that one. But if you use the interactive mode instead, it would recommend you certain defaults. So I think I'm happy with that. I will just run it. It will first do a few checks, then it will provide me with a summary. Looks good. I don't need to make any changes here, so I'll just say proceed with Bootstrap. So it does the cloning. It's creating the environment. Now it's creating resources. And then the actual resource group and the managed identities, it's using deployment stack, which is a really nice thing. I love seeing that, because even though deployment stacks have been GA'd for quite some time now, a lot of companies are using plain deployments, which I think is a shame. And when this is done, we can check and validate if everything is all right, but this tool is clever enough to validate all the steps for us. So if something fails, it will tell us immediately. It's taking a while, but now I can see that it's proceeding with the GitHub configuration and the setup seems to be complete. So let's have a look. Let's switch to the repos, Azure Project Beta. It used my template repo with all the content. When I look at the settings, it created environment secrets for client ID, subscription ID, and tenant ID. For branches, there should be this branch protection, but let's check the environment first. So there is a dev-ic apply and dev-ic plan, and there are 2 protection rules on that one. So require reviewers and allow admins to bypass the configuration. Nice. Let's have a look. Not the PowerShell gallery, but the portal. Let's see how it looks like there. Source groups. It was beta. You can see there are 2 managed identities. Each has its own role assignment. That's a contributor, that's apply, and plan is a reader. So the way that Stu structured the management of managed identities is that it creates 2. It follows the Terraform logic with a separate plan and apply. But what I realized when I try to run that workflow now that I have in this repo is that this is not entirely compatible with those reusable workflows that I have. If I try to run any of these actions, it will fail. And the reason for that is that my reusable workflows expect secrets with different names. And in addition, as you can see, those secrets are in 2 different environments. So there's a small glitch. The way you can fix it is that instead of using those reusable workflows that I presented in my repo template, you can use Stu's. So there is a separate repository in his account, GitHub Azure IAC templates, where, as you can see, he has workflows for Bicep, plan and deploy and apply. And in the README, you can see how you can call it from that the actual project repository. How would you go about the inputs that he's using? So from that small caveat, I would need to either fix my reusable workflows or make sure that I provide the values for those secrets in the way that this automation creates them. But otherwise, it looks really good. That's all what I had for you today. I hope you enjoyed the session and you learned something new, or it was a refresher for you. Feel free to reach out using the social media I mentioned at the beginning with your questions, feedback, or ideas. Good luck with building your next infrastructure as code project, and don't forget to check other sessions on Azure Back to School website. Bye.